Okay, so yeah, my name is Alvaro Muñoz. I'm also known as a Pond Tester in Twitter and GitHub and social networks. I work as a principal security researcher with Fortify, basically in the static code analyzer team. I don't consider myself a speaker, but I happen to present at different conferences like Black Hat and DEF CON and so on. And I have a special interest in remote code execution vulnerabilities through web applications. So I basically successfully exploited products and vendors like Microsoft, Oracle, Workday, Salesforce, and so on. Actually, the Microsoft one of the Microsoft ones, I'm going to present today. So apart from that, I have some experience around serialization. Back in 2012, I was looking at different REST API implementation libraries like RESTlet and RESTEC, and I was able to find some remote code execution vulnerabilities by abusing XStream and XML decoder. And then in 2013, I started looking at Java binary deserialization, right? At that time, and to my knowledge, this was the first public remote code execution gadget available for Java deserialization, but unfortunately, no one was paying attention to Java deserialization at those days. So it was not until 2015 when Gabriel Lawrence presented the gadget in Apache Commons collection that people started looking at Java deserialization vulnerabilities. I started fixing them and finding them and so on. So that's why I'm saying, unfortunately, because we could have saved ourselves a couple of years by starting looking at that in 2012, at least. So at that time, when they released this gadget, I started looking in Java deserialization again. I was able to find multiple remote code execution gadgets, was able to bypass the standard mitigation technique, which is called as look-ahead object deserialization. And I was able to find the gadget in the Java runtime, which means that you don't require third-party libraries to be present in the class path in order to exploit these vulnerabilities. So then I moved to JSON deserialization, which I presented last year at Black Hat and DEF CON. But most of this is Java, right? So at some point, I changed my interest, and I started looking at .NET. And this is what this talk is about. We're going to see a brief introduction into serialization formats, and then we will see what are the most popular and used .NET serializers, both by Microsoft and third-party libraries like JSON.NET. If we have time, we will see some demos, including this Microsoft remote code execution in Azure. And then we will move to see how we can detect, find these vulnerabilities, and then fix them. So serialization 101. So I don't know why, but in English, the Americans, I guess, and British people use pickle for serialization. To me, pickle is just this green vegetable, but it's actually very famous, like the Python library is called Pickle. This talk by Chris Frohoff was called marshalling pickles. But well, to me, it makes a great excuse to use Rick and Morty drawings in my slides. And well, this is Rick, obviously. And if, well, you have an instance of Rick that is living in your VM, and at some point you want to put this, this object into a different representation, so you can store it in the file system, for example, or maybe put it into a database, or send it across the network, or whatever. So you put it through the magic portal, and then you get Pickle Rick, right? And this is the serialization format of Rick. At a later state, you may want to recover this instance of Rick in your VM, so you basically reconstruct the object based on the information on the serialized format. So the thing that is key for deserialization attacks here is that we are not sending just the pickle, but we are sending also this pickle Rick, right? And this is called the type discriminator. The type discriminator is nothing else than the class name or the type name that you are sending along with the data. And so if you're familiar with Java deserialization, for example, so you were probably familiar with, well, this is the binary format, and this is basically the ASCII representation of the class name. And basically, the server is going to use these class names to actually instantiate and reconstruct the objects at the server side. So that's Java serialization. In .NET, for example, in JSON.NET, you have something similar, but this is JSON format, right? So you have type attribute here that contains something that looks like .NET assembly, .NET type name. So If the attackers are able to change those type discriminators, then they will be able to force an instantiation of an arbitrary class during the deserialization process. And that will basically allow the attacker to instantiate a multi-instance instead of the RIC1. So there is nothing really dangerous on getting the server to instantiate or call the default constructor for a different or arbitrary type, because default constructors are just parameterless and they don't do anything bad normally. But normally, in order to fully reconstruct the object, there are some callbacks and some methods that may get invoked, right? So for example, if you're familiar with Java Deserialization, you have the read object and read resolve callbacks that are invoked in order for, these allow the developers to fully reconstruct the object. So maybe you need to initiate or initialize something or register the object in a JNDI context, or, I don't know, notify someone about the deserialization or something like that. So in .NET, we also have this kind of callbacks. We have the deserialization constructor. We have some deserialization callbacks, like on deserialization, for example. And we also have some annotations that we can use to let the framework know which method should be invoked during the deserialization process. Apart from the binary format, normally in JSON and XML, the setters are also invoked, right? So basically, we invoke the default constructor, we reconstruct the object, and then we invoke the setters in order to populate the values to the different properties of the object. So with that, we fully reconstruct the object, but there is some code that is executed. So gadgets. Gadgets are basically different types that are sitting in the class path of the application that is deserializing. You can provide the type name, but you cannot provide the type bytecode. So these types are special because if they are provided with some malicious values, they can lead to arbitrary code execution or to something bad, like removing files or doing something bad. So this is a simple example that is a gadget, a setter gadget. So it starts with invoking some setters. It's in .NET in the class System Windows Data Object Data Provider. And I like to use this for explaining what a gadget is because it's very simple, right? So you have 3 different setters that when you invoke them with attacker-controlled data, they will basically initiate a chain of calls that will end up invoking the invoke method on instance, right? This one down here. So basically there we are using reflection to invoke an arbitrary method on an arbitrary object instance, passing some arbitrary method parameters. And those arbitrary values all come from the different setters, right? Like the values that you pass to the setter. So this is an example of a payload for JSON.NET. Basically, what we are saying here is, okay, we are going to deserialize an object data provider. So the server is going to instantiate the object data provider by calling the default constructor, and then it's going to invoke the setters for the object instance, the method parameters, and the method name. And because we saw that these setters will eventually call the reflection code to invoke the method, then we will be able to get arbitrary code execution if we can provide this piece of JSON to a vulnerable JSON.NET endpoint. So with that, I think that's enough about gadgets. I wrote this application called WhySoSerial.NET. There is a Java version that will basically generate payloads for you. The Java one is just for binary format, for the Java binary format. This one supports different serializers, right? So you have to pass the formatter that you want your data to be, your payload to be serialized. So for example, you have to specify what gadget do you want to use, what formatter do you want to use, and what command do you want to invoke. Okay, so with that, let's move to the .NET serializers part. Basically, this is nothing new. Back in the days when I was playing with the REST endpoints in 2012, James Forso from the Google Project Zero was presenting at Black Hat that some malicious code could be executed as the result of .NET deserialization. So at that time, he found that BinaryFormatter and NetDataContractSerializer both could lead to some dangerous execution, but at that point, there was no remote code execution gadgets, right? So it happened like in Java. The Java deserialization vector, it was a very well-known vector since at least 2007 or something like that. but until 2015, when this Apache Commons Collection gadget, remote code execution gadget, was published, no one was actually paying attention and actually started fixing things. So same thing here. It was known that binary formatter was dangerous, but it was not until last year when a colleague of mine, Alex Miroz, and James Forso and myself published 3 different gadgets for remote code execution when people started looking at fixing .NET serialization. So we extended the list by James Forso by looking at other serializers. So James already said that binary formatter is serialized, is vulnerable in the default configuration, but binary formatter is also used by other formatters, right? So, for example, the binary message formatter is used by the Microsoft message queue, the equivalent to ActiveMQ, for example, in Java. So if you are capable of sending arbitrary message to a message system, they will be using binary message formatter that is as vulnerable as the binary formatter one. Also, object state formatter, that is the one that is used to serialize the ViewState data in ASP.NET, it's using object state formatter. So because of that, we will be able to get arbitrary code execution in ViewStates if we know how to modify the ViewState without breaking the signatures. But we will see that later. So James already told us about NetDataContractSerializer, but also SOAP formatter using web services, FastJSON and SweetJSON third-party libraries. They are also vulnerable in their default configuration. So this is what I think is the most popular and used vulnerable pattern in .NET. That is basically take some objects and then serialize them using binary formatter, and then base64 encoding that and putting that into a cookie. Right? That means that when the cookie gets back to the server, the application is going to deserialize that data, and there is no HMAC here. There is no nothing that prevents the attacker from modifying that and injecting the payload. So I first find this vulnerability in a site or a company called App Harbor that is basically like Heroku for .NET applications. And if you browse the application, you will find that at some point they were assigning some cookie with some values that it starts with AAE, AAAD, which is the magic number for .NET serialization, which made them basically vulnerable. So we reported the issue, they fixed it, and then we found that they even had a blog post explaining how to do that in your own applications. Like, you can use the cookie temp data provider with binary formatter and then make your application vulnerable in that way. So now this blog post is deleted, but I found that this same advice was everywhere. It's like really tens of blog posts. It's in GitHub, in different gists. And also it was used by Microsoft in an old version of the ASP.NET MVC framework. So at some point in 2013, probably after the James Forso talk, they removed this cookie temp data provider from the ASP.NET MVC framework. But I think that the damage was already done. Many frameworks and many developers were already using this pattern in their applications, as we will see now. So a simple example. Well, this is a vulnerability that I found in Microsoft Azure network. Basically, you can expose your intranet, right? This box here is your intranet, and then expose your web applications to the remote workers right here by using what is known as the application proxy service. And that means that you will install a connector in your network, and then your employees will basically access a URL that is provided by Microsoft, and then they will be redirected to the Active Directory login that will basically check your credentials in your own Active Directory. And if everything is correct, you will be given a token that you will provide to the application proxy server, and then you will finally authenticate to the web application, right? So I'm pretty sure that you're familiar with this login page. So basically, I don't know if you can read anything from the, so, well, I can't stop it, apparently. OK. Well, you can't read anything, but this is the URL provided by Microsoft. You can change it and put any domain you want. And then you access your remote application. You are redirected to Microsoft login, right? You don't actually have to log in into Microsoft. This is a pre-authentication remote code execution vulnerability. What I'm doing here is basically I'm just deleting the cookies for this page before sending the request to Verb. So I'm going to do that right now. And basically, what I will do is send this request to the repeater. And the response is basically the redirection to the Microsoft login page, and then a cookie that I don't think that you can read it, but it's basically starting with this magic number again, this AAE. So I basically just, well, if we take this value and we take it to the decoder to see what is inside of this base64 blob, we will see that there are some type discriminators, some type names. So this is basically using .NET serialization. Specifically, it's using BinaryFormatter. So at that time, I haven't written YSOSerial.NET, so I use my own gadget generator at this point. And basically, what I'm going to execute is the NS lookup to my own DNS server, and basically, I'm going to exfiltrate the name of the computer name variable to verify and to prove Microsoft that I was executing that in their servers and not in the intranet servers. So that takes a while because the VM was very slow that day. If I try that locally, I will get a connection from my own servers. Well, you can't read anything, but there is Muñoz A, that is my own computer name. And now if I copy-paste the payload that is generated and that you can generate now with YSOSerial.NET, if you copy that to the request and send it to the application proxy, remember, we are not even authenticating, so this is pre-authentication remote code execution in Azure network. We just copy that. We change to our DNS server, and as soon as we send a request, we will see that it's being executed in the Microsoft servers. So we'll get like 4 different resolutions right there. And well, you cannot read it, but this is not Muñoz A, that is my computer name. This is Microsoft computer name, and those are Microsoft IPs. So with that, well, if you send the request again, you get the connection from different servers, which means that these application proxies are working like in a load balanced way, which means that if you compromise the application proxy, you can now get access to all the intranets that are being proxied by the server. So with that, those were the formatters that were vulnerable in the default configuration, right? Like binary formatter, you should never use that with untrusted data. There are a different set of formatters that are vulnerable if you configure them in a special way, or if you let the users provide not just the data to be deserialized, but something else that is called the expected type. So for example, if you use DataContractSerializer or XmlSerializer, these are serializers that are okay to handle untrusted input, untrusted data, but you should never use or never let the users to control the expected type. So that's exactly what .NET Nuke, that is a content management system, or actually the most popular content management system in .NET, was actually doing. So basically, again, I don't know if you can read anything, but there is a cookie that contains this XML item that comes from an unsigned cookie that the attacker can control. And then this XML, we get the type name extracted from the XML, and then we initialize the XmlSerializer with that type name. So now the attacker can control the expected type. And by expected type, I mean that, for example, they are only going to work with that expected type, right? So for example, if you are sending or expecting a shopping cart, you cannot send an object data provider, like the gadget that I showed you before. You can only send and deserialize a shopping cart. And then at a different point, they deserialize the rest of the cookie, and then this CMS was vulnerable to remote code execution. I don't have time to show you the video, but it's in the DEF CON talk if you want to check it. And then there is a different set of deserializers that are vulnerable depending on the configuration of the deserializer. So for example, JavaScriptSerializer, That is the native solution for JSON serialization in .NET, the one that is used, for example, by ASP.NET. You should never use that with a type resolver. If you initialize this JavaScript serializer with a type resolver, that basically means that it's going to include the type discriminators, the type information with the JSON data, and then it's going to process that, and that is going to allow the attackers to control which types are going to be reconstructed, and then that will lead to arbitrary code execution. So that's JavaScript serializer. JSON.NET, that is the most popular JSON library for .NET, has the same problem. In the default configuration, is secure, but if developers enable this type name handling setting, and they put anything other than the known values, so for example, type name handling objects or auto or arrays, that means that the type information will be included in the JSON data, and that will allow the attackers to actually get arbitrary code execution. So that's actually what a framework that is called Breeze was actually doing. So Breeze is a framework for entity management, database entity management. So that what they do is basically they expose your database entities through a REST API, right? So for example, they expose a REST endpoint to add a new record or to delete a record, to modify a record, and so on. And they do that automatically. So they have this demo application for developers to learn about the framework. And well, this is a very simple application that allows you to handle and manage different car models. So for example, you can change the name of a model and submit it, and it will be persisted in your database. If we send that to, through Burp, we can actually change, for example, the name of the car model. And if you change that and send it to repeater, you will see, or I don't know if you will see, but there is an empty dictionary here that is called save option, and it's an empty object or an empty dictionary. Because this is using JSON.NET with the type name handling, what I'm doing here is basically using the object data provider gadget that I showed you at the beginning of the talk. Remember the one that was using the 3 setters to call any method, and I was basically using that to invoke the process.start and invoke the calculator. So you copy paste this directly into your request. And now if we go back to the server, we can check that there is no calculator running. As soon as we send the request, it will be deserialized. The object data provider will be instantiated, the setters will be invoked, and the calculator will be executed. So that was about a brief introduction to some of the serializers. Now, how can we find them, right? How can we find vulnerable endpoints? So one simple way is by inspecting the traffic. As I said, this is the magic number for BinaryFormatter, and this is probably the most used one. If you search in Sodan for it, you will find like 500 or 600 instances still alive. Then, well, I wrote a very simple plugin for Burp that I released today. It's very simple. It doesn't mean to be very accurate, so it has some false positives because this magic number can appear in images, for example, or it may report a ViewState that contains serialized data, but then it's signed, so you cannot change that without the server realizing. But yeah, it detects different magic numbers, not just the BinaryFormatter one, and different encodings, not just base64. So it's kind of useful to detect vulnerabilities like the Azure one or some others. You can also use an active approach, like black box approach, sending a payload that if gets deserialized will make the server to sleep for some seconds, or to initiate a DNS resolution that you can detect in your server. Or you can use IAST, like instrument your application, instrument your VM, and see if some untrusted data reaches some of the deserialization endpoints. If you have access to the source code, like I did, for example, for DNN or for Breeze frameworks, you can actually run a static analysis and look for untrusted data flowing into one of these things. Like, for example, single data flows are very simple to identify for BinaryFormatter. Or, for example, for XmlSerializer, remember that there were 2 different flows that were required. One flowing into the data to be deserialized, and another one flowing into the expected type. So again, it's simple. Most of the static analysis tools should support that. And now, the third part of the talk is how to fix vulnerable endpoints, or how to verify if the vendors are actually applying good fixes. So the first way is to stop using serialization. I mean, this seems like rather stupid, but I found many cases, some of them I cannot disclose yet, but that they are using serialization to serialize strings, right? One case that I can talk about because it's already fixed is in the Nancy framework, which is a web application framework, and instead, well, they have this NCSARF cookie for CSARF protection, but instead of putting the token directly into the cookie value, they were serializing the string into an object and then base64 encoding that data into the cookie, which basically made them vulnerable to remote code execution instead of CSARF. So I don't know. Also, if you don't really need type discriminators, don't enable them, right? So that was the case, for example, for the Breeze framework that I showed you. Once that I reported the issue, it took them like 12 hours to fix the issue because they realized that they were not actually using the type information, right? When they wrote the framework for the first time, the clients were meant to be .NET clients, so they were exchanging some types and some .NET serialization, but at some point, they added a JavaScript client. And because of that, they stopped using the type information in .NET because it was useless. But no one disabled that, and then they left the framework vulnerable. So this is the way of protecting JSON.NET, for example, like Breeze framework did. Basically just explicitly called type name handling and then pass the non-value to make sure that the data is not, the type information is not included in the data. So the first approach was to stop using it. The second approach is to verify that no one is tampering with your cookies, for example. So if you do that, always use HMAC, never use something like MD5 or SHA-1 with the secret and the data because that's vulnerable to hash extension attacks. And this is the way that, for example, App Harbor or Azure fixed the issue, right? They just included a signature, an HMAC, so they were able to verify that the client was not actually changing or tampering with the data. So that should be the case, like, for example, if you cannot stop using deserialization and you have to put something into the client side because maybe, I don't know, for performance reasons or whatever, you have to sign it and make sure that no one is touching that. As I said at the beginning, that's what Microsoft did with the ASP.NET implementation of the cookie temp data provider. In the first version of the framework, it was vulnerable, but then they fixed it using the data protection API. And then they also fixed the ASP.NET ViewState that we will see later. So it's very simple. Just use the data protector API, protect the bytes, and that will basically sign and encrypt the data using the web config encryption and validation keys. So ViewState is an interesting case. At the beginning, like many years ago, they were not signing or encrypting the ViewState. So the ViewState is basically a representation of the state of a given page. So instead of keeping that server side, they send it to you. And then when you request or send the request back to the server, they take that data and reconstruct the previous state of the page. So as I said, they are using object state formatter which is vulnerable to remote code execution attacks. So if you allow the client to change the view state, that will lead to remote code execution. So at some point, they included the option to enable an HMAC and encryption to the view state because, well, at that point in time, there were no remote code execution gadgets, but if you could change the view state, you could change the application logic and lead to different bugs. So in 4.5.2, they even ignored the enable view state MAC. So even if you put that into false, the ASP.NET is going to ignore that, and it's always going to encrypt and validate and include the HMAC for the view state. They even backported that to 1.1. So if you are not ignoring the patches, you should be protected. So when I was writing this slide, I was curious about how many patched servers were in the network, and basically I checked with Sodan, and out of the 10,000 results that they gave me, 200 were vulnerable. So this made like a big, interesting, I don't know, probably Bitcoin miners, botnet. Anyway, so at some point, they improved the cryptographic posture of the view state, right? Because if you are able to leak the encryption and validation keys, you can actually use that to change the view state, and then it will lead to remote code execution. So Microsoft decided to add some additional protection by using a key derivation function and something that they call the purpose. And the purpose is nothing else that some strings, right? So I don't know if you can read it, but there is a primary purpose and some specific purposes. So when you visit a URL, they generate 4 different strings, and these 4 strings will be used to actually derive a new set of keys. So instead of using the encryption and validation keys that you have in your web config file, they will derive some keys that are unique for the specific URL that you are visiting. So for example, if you visit the account register URL, the first purpose is always going to be the same. It's just describing the purpose of the encryption that is going to be client state, meaning that it's going to be used for the view state, and that's not going to change. But now the second string is something that is called /account, right? This seems like rather predictable given the URL that you are visiting. The third one is account underscore register underscore ASPX, which again is rather predictable and also easy to guess. And the fourth one is this ViewState user key, which contains something that looks like an arbitrary unique token, like 77 something. But now if you go and check the cookies for this page that you are visiting, you will see the anti-cross-site request forgery token is actually using the same value as the view state. So now you have all the different pieces that you need to derive the new keys and get arbitrary code execution. Still, you need to be able to leak the encryption and validation key. This is the key point here. So the whole idea of these slides is to remark that you need to be very careful with not leaking the keys. How can you leak the keys? Well, if you have an XXC vulnerability, for example, or maybe if you haven't patched these very old CVEs like 2010, 2015 that allowed users to actually leak the web config file. From Troy's hand, I found that apparently, I haven't seen that myself, but apparently there are some error pages that can leak the encryption and validation keys. And last but not least, in GitHub, you will find hundreds of keys. So if you are lucky enough that someone is deploying the application with the very same keys, then you may be lucky and get arbitrary code execution. So the final recommendation here is to use encryption, to get IIS to encrypt your web config file, at least some sections of the web config file. So even if you get like an XXC vulnerability in your application, the attackers won't be able to get the encryption and validation key and be able to actually escalate from XXC to remote code execution. So we talk about the stop using it, signing it, and then binding it is the third approach. So this is a very dangerous approach, but it should work, but you have to be very careful at implementing it. Basically, the idea is to constrain which types are going to be allowed during the deserialization, right? So you can basically implement a serialization binder, implement the bind to type method, and then you are provided the assembly type, the assembly name, and the type name, so you can check them right before this type get instantiated, and then decide if you want to continue with the deserialization or just discard it. So if you go and use this way, I don't know if you can read that in red, but never use blacklist. They are very easy to bypass. I will show you now the bypass gadgets, and never use a very broad whitelist approach. I will show you an example now. So this is an example of a good security allow list serialization binder, which basically is implementing the serialization binder interface and basically is checking for a specific strict list of allowed classes. And if the classes that are allowed are not found, it's throwing an exception, right? You should never return null, because if you're returning null, then it will default to the default binder, and then it will allow the exploits to go on. So once you have your serialization binder, you have to assign it to the binder property and then deserialize the untrusted data. That's the way of using a serialization binder. So as I said, never use a broad whitelist approach. This is actually pseudocode from a very popular Microsoft product. I'm in the process of disclosing this vulnerability, so I cannot tell the name of the product, but the code looks very similar to this, right? And at some point, they are checking if the type starts with Microsoft dot, put the name of a very popular Microsoft product here. And if that's the case, then they will allow you to continue with the serialization, because they think or they trust that they don't have remote code execution gadgets in their namespace, in their own classes. And maybe that's true, and they don't have this kind of gadgets in their namespace, but what is probably sure is that they contain bypass gadgets. So what is a bypass gadget? Basically, it's a type that initiates a nested deserialization from a deserialization constructor, right? So you are protecting the outer deserialization, and maybe you are binding that and checking that these malicious classes are not used, are not deserialized, but then you are allowing the deserialization of this class that it's going to initiate an inner or nested deserialization, which basically won't be used in any binder. So it will allow the deserialization of untrusted, malicious remote code execution gadgets. So again, in your deserialization binders, never use, or if you are checking for the protections, maybe doing some back hunting, if you see that they are using is assignable from, or if you see, for example, that they are returning null, that means that this binder can be bypassed. Also, if they're using reflection in their binder, it's very easy to get a DOS and DOSD application. So that was the third approach, binding it. The fourth approach is replacing it, right? So maybe you don't really need to send all this type information along with the data. So maybe if the client and the server can agree that they are going to exchange, I don't know, a user instance, maybe just sending the name, the address, the last name, and so on, it's enough. And you don't have to send that they are using com.acme.user or any type name. So that's the approach that Google Protocol Buffers use. So that's a good approach if you want to deserialize untrusted data. Last but not least, JSON and XML are also secure, but as long as you don't include type information, like we saw, for example, in JSON.NET. So that's all I had for you. So if you have any questions. No questions?
Any questions, someone?
Oh, there's a question.
Thank you for the talk. I was wondering, did you try to report all those machine keys? Because you can do quite a few things with those machine keys from GitHub. Or did you find any issues in modern or in popular software?
So I haven't reported any of them. There are literally hundreds of them in GitHub. And I guess that, for example, if these are open source projects or open source frameworks, that the people that are going to use those frameworks are going to change those keys. Otherwise, if you know that a specific framework is using those keys, and you can look for websites using those frameworks and try to exploit that. But yeah, I don't know. We probably for the most popular one, we should try to find if they are using those hard-coded keys and report that. That actually makes a very good CTF task, right? So being able to leak the keys, then use the key derivation purposes and all the stuff. So maybe for the next year. Okay, so no more questions?
So, okay. Thank you for being there, and thank you for your talk.
Thank you.